Welcome everyone. Today I will discuss some problems of definite integral involving greatest integer function. Problems of definite integral using greatest integer function. So, what is greatest integer function? You know. Try to recall 1.4. So, value will be integer but not exceeding 1.4. So, this is 1. 1.9. This is also 1, not approximate value. If you take 2, then it will be greater than 1.9. And if it is minus 1.2, and look, this is minus 1, this is minus 2. So 1.2 minus 1.2. So value should be integer but not exceeding 1.1. So this is minus 2. So if it is negative, delete fractional part and add minus 1. So if it is integer, then it is 3. This is minus 2, then also minus 2. Not exceeding x. So greatest integer function, it is denoted by third bracket x. Greatest integer, definition is greatest integer not exceeding x, not exceeding x. It may be equal to x but not exceeding x. So greatest integer value should be integer but not exceeding x. It may be equal to x. So look, see, this is minus 2. And you know, it is periodic function. You also know, I have already discussed it, graph of it. So this is 1, then 2, if you write it 3. So this is 1, this is 2, this is 3. So in 0 to 1, value is 0, value is 0. In 1 to 2, value is 1. In 2 to 3, value is 2. In 3 to 4, value is 3. So it is also called step function. It is piecewise discontinuous. So you know, it is not continuous at integral values but continuous at non-integral values. We need the idea of graph also. So this is the graph. It is also called step function. It is also called step function. This is y equals to 1. This is 1 less than equals to x less than 2. This is y equals to 2. 2 less than equals to x less than 3. So recall again, this is 0. If 0 is included, 1 is not included. This is 1. This is 1. 1 is included but 2 is not included. That is why it is 1. This is 2. And so on. This is 3. This is 3. 3 is included but 4 is not. And it will be continuing. It will be not terminating. So this is greatest integer function. So it is not continuous at integral value. Now we solve some problems of greatest integer functions. So 0 to n, third bracket x dx. So you look the discontinuous point here n is integer, n belongs to z. So 0 to 1, we can write it as 0 to 1, 1 to 2, 2 to 3 by property of definite integer. Then dot dot n minus 1 to n third bracket x dx. So it is not continuous at 1, 2, 3, 4 and dot dot integer point. So you can write it by this very property, a to b fx dx equals to a to c fx dx plus c to b fx dx, where c is a point in between a and b. This is the relevant property. Now, in 0 to 1, I have already discussed it. 0 is included, but 1 is not. So, this is 0 to 1, 0 dx. In 1 to 2, 1 dx. 1 is included, 2 is not included. Then 2 to 3, 2 dx. And similarly, last one is n minus 1 to n, the lower n minus 1 dx. N minus 1 dx. So, first one is 0. So, this is x, 2, 1. This is 2x, 2 to 3. Then it is 3x, 3 to 4. And finally, n minus 1, this is x. So, difference of upper limit and lower limit is 1. So, this is 1 plus 2 plus 3. 2, 3 minus 2, 4 and dot dot n minus 1. So, it is sum of natural number n into n plus 1 by 2. So, here formula is n into n plus 1 by 2 if it is up to n, but here n is replaced by n minus 1. So, n minus 1 plus 1 by 2. So, n into n minus 1 by 2. So, you have to recall this result. If it is simple function, only greatest integer, then value is 0 to n, n into n minus 1 by 2. So, for problem number B, 0 to 10, so you replace n by 10 and you get result. So, if it is problem of competitive West Bengal joint, then what will be the answer? 10 into 10 minus 1 by 2, that is 45. That is 45. So, greatest integer function is piecewise discontinuous function. It is discontinuous at integer point. So, expand it at the point of discontinuity. Then look problem number 2. Problem number 2. 0 to 1.5, third bracket x square. So, x square should be integer in between 0 to 1.5. So, look x square. It is 0 at x equals to 0. At x equals to 1, this is 1. Then integer, next integer of 1 is 2. So, this is root 2. So, this is 2, x equals to root 2. Because root 2 square is 2. Now then root 3 square is 3. But root 3 is greater than 1.5. So, no need of taking root 3. So 0 to 1.5. So you expand it in this form. 0 to 1, third bracket, x square. Then 1 to root 2. 1 to root 2. Third bracket, x square dx. Now then it is 3, x equals to root 3. But root 3 is greater than, this is 1.73. So it is greater than 1.5. So no need of taking this. 1.5 third bracket x square dx. Now third bracket x square is 0 to 1. We take the lower value. So 0 to 1. This is 0 dx. Value is 0 to 1. And this is 1 to 2. So value of third bracket x square is 1 to 2. So we take 1, the lower. Then 2. And what is third bracket x square? 2.25 at x equals to 1.5. So 2.25. What is third bracket x square? So this is 2. This is 2. So 2. So we are getting root 2 to 1.5 to dx. Now listen again. You have to take integer value at x square. So 0 square is 0, 1 square is 1. So 0 to 1. Then next integer is 2. So root 2 square is 2. So 1 to root 2. Then root 2 to root 3. But root 3 is greater than 1.5. So you stop here. Root 2 to 1.5. Then value of lower limit. 0 square. So 0, 1 square. This is 1. Root 2 square. This is 2. Now simplify it. This is x. First one is 0. So x root 2. This is 2x 1.5 root 2. So root 2 minus 1. 2 into 1.5 minus root 2. So 3 minus 1. This is 2. 2 minus root 2. Plus root 2 minus 2 root 2. So answer is 2 minus root 2. 2 minus root 2. So we are getting answer as 2 minus root 2. So you should remember that x square should be integer. You have to take value, that is why it is root 2, then root 3 and so on. Root 3 is not taken because root 3 is greater than 1.5. Now problem number 3. Exactly same problem. Now we consider problem number 3. This is exactly same that of 2. So only limit is 0 to 2. So 0 to 2, third bracket x square dx. So our main aim will be to expand it at sum of several limits so that x square equals to integer. So 0 square is 0, 1 square is 1. So first one is 0 to 1 x square dx. Then 1 to root 2, third bracket x square dx. So 1, this one is 2. Then since it is x square, root 2 to root 3, third bracket x square dx, and this is root 3 to 2 square, that is 4, third bracket x square dx. Greatest integer function. Third bracket means greatest integer function. Now, up to this is same. So, 0 to 1. So, lower limit. So, this is 0 into dx. 1 to root 2. So, 1 to 2. So, this is 1 dx. Root 2 to root 3. This is 2 dx. Root 2 whole square. Then, this one is root 3 to 2, 3 dx. So, only this one is extra. In the earlier problem, last one is root 2 to 1.5. Now, first one is 0. Second one is x. Root 2. This is 2x. Root 3 to root 2. This is 3x. Root 3 to 2. Now, put the values. So, root 2 minus 1. 2 root 3 minus 2 root 2. 6 minus 3 root 3. 3 root 3. Now, six minus 1, this is 5. Minus 2 root 2, this is plus root 2. So, this is root 2. Minus 3 root 3 plus 2 root 3. So, this is minus of root 3. So, this is our final answer. If it is problem of competitive exam, different options are given. You have to take the correct option. So, remember it, you have to take the interval so that x square equals to integer. X square equals to integer. Then, fourth one. Fourth one also exactly same, that of 2. That of 2. So, 0 to 1.5 x into third bracket x square dx. Here x is extra term. So, same as earlier, 0 to 1 x into x square dx. 1 to root 2 x into x square dx. Then root 2 to root 3. Root 3 is greater than 1.5. So, that is why we terminate here. So, root 2 to 1.5. Now, put value of third bracket x square. 0 to 1 x into 0. 1 to root 2 x into 1. Root 2 to 1.5 x into 2 dx. So, first one is 0, second one is x square by 2, root 2 to 1. This is x square, 1.5. So, half of root 2 square, that is 2, minus half, 1.5 whole square, minus 2. So, this is 2.25, 2.25 minus 2, and this is 1 minus half. So, half, this is 1 minus half is half, and this is 2.25, this is 1 by 4. So, final answer is 3, 4. So, only calculation. So, problem number 2, 3 and 4, they are of same type. Now, consider problem number 5. So look, this is I, 4 to 10, third bracket, x square, x square x square minus 28x plus 196 dx. So call it 1. Now look at the problem. So within this third bracket it is x minus 14 whole square, x minus 14 whole square. So look, so we cannot expand it. So this is not problem of previous type. Here you have to use property of definite integral. So King's rule. Here lower limit is 4, upper limit is 10. So you know a to b fx dx, King's rule. A to b f of upper limit plus lower limit minus x. We have done so many problems using it. So x is replaced by upper limit plus lower limit. So 14 minus x, upper limit plus lower limit, 14 minus x. So this is 14 minus x whole square, and this is actually it is x minus 14 whole square. So x is replaced by upper limit plus lower limit minus this. So we are getting 14 minus x minus 14 whole square, then greatest integer function, obviously dx. So this is 4 to 10. So x square minus 28x plus x square, and this is x square minus 28x plus 196. This is 196, and this is 14 cancel, x square. This is, now look at denominator of 2 and 1 are same. So if we add 1 and 2, so 1 plus 2 implies this is also I. 2I equals to 4 to 10. So this plus this, so same mu, so it will be dx. So you look, x square plus this, and denominator also this. So this is 10 minus 4, this is 6. So I equals to 3. So what is the final answer? Final answer is 3. So you have to recognize the problem. Which property you have to apply. Now you know, for this type of problem, shortcut rule is upper limit minus lower limit by 2. So 10 minus 4 by 2, that is 3. Because you are getting 2I equals to dx. And finally, problem number 6. Problem number 6. 0 to infinity 2e to the power minus x dx. 0 to infinity. So look, fx equals to 2e to the power minus x. So what is f dash x? So this is less than 0 for all x. So we can say fx is decreasing function. Decreasing function. Fx is decreasing function. Look, at x equals to 0, it is third bracket 2. It is third bracket 2. And as x increases, since it is decreasing function, value of 2e to the power x also decreases. So at x equals to 0, so 2e to the power x equals to 2. At x equals to, as x tends to infinity, 2e to the power x tends to 0, minus x, because e to the power minus x tends to 0 as x tends to infinity. Now, we want value of this as integer. Suppose 2e to the power minus x equals to 1. So, we can write e to the power minus x equals to half. So, e to the power x equals to 2. So, x equals to log 2. At x equals to log 2, value is 1. At x equals to log 2, value is 1. Now, since it is decreasing function, as x greater than log 2, so this value 2e to the power x, this value will be in between 0 to 1. At x equals to log 2, it is 1. Since it is decreasing function, for greater than 2, it is log 2, it is 0 to 1. 0 to 1. So, for suppose x equals to log 4, if you take x equals to log 4, e to the power minus 4 log, e to the power 2 e to the power log 4. So, base is e. So, 2 e to the power log 4 to the power minus 1. So, this is 2 and this is 4 to the power minus 1. So, this is half. So, its value lies between 0 to 1. It is decreasing function. At x equals to 0, value is 2. Then this type, value is at x equals to log 2, value is 1. And for greater than log 2, it lies between 0 to 1. And you know, for 0 to 1, the value of greatest integer function is 0. So, you have to recall this result. So, expansion will be 0 to log 2 e to the power minus x dx plus log 2 to infinity 2 e to the power minus x dx. Now, since in between log 2 to infinity the value is less than 1, so greatest integer function, this one is 0. And at 0 it is 2 and at log 2 it is 1. So, what is the minimum? So, 0 to log 2 1 dx. 0 to log 2 1 dx. It lies between 1 to 2. So, it will be x and this is log 2 0, this one is 0. So, finally log 2. So, this is also most important problem for competitive exam. So, listen again, 2e to the power x. So it is decreasing function. So value decreasing, you know, as x increases, it decreases. So at 0, it is 2. Then value decreases. So at log 2, this is 1. Then greater than log 2 to infinity, it is 0 to 1. That is why this greatest integer function is 0. So finally, we are getting value as log 2. So this type of problem, these are included in competitive exam only, not in board syllabus. So today I have solved some important problem of definite integration where greatest integer function are appearing. So you have to recall the definition of greatest integer function. So it is piecewise discontinuous at integer point. So using this concept, you have to expand it in different interval. Then you have to solve it. So you try to solve this type of problem using greatest integer function from any standard book. Thank you for today.